Hi guys, today we're going to learn about U-substitution with definite integrals. So the first thing that you can see here is recognize that you have that your U is going to be equal to x squared plus 1. After that, you take the derivative of your U, which is going to be 2x dx. So what I would recommend you to do is you can recognize that you have the x and the dx, but the 2 you don't have. So I would pass the 2 dividing to the other side, having x and dx as we have done before. So after this, what I would do is you have upper and lower limits of integration. So I would do the lower limit of integration. I would plug it here. Okay, so you would have 1 squared plus 1, that gives you 2. And then the upper limit of integration, you have that it would be 2, so you plug it as the u, so it would be 2 squared plus 1, which you have that it's 5. So at this point, you are like, I'm going to substitute all my stuff here with u, so you have that the integral is going to be from 2 to 5, because those are your new limits of integration. Okay, and then you have that it's going to be u to the power of 3, okay, du divided by 2. Okay, the beautiful part about this process is that since you change your x's to u's, you don't need to go back to x's anymore, and you can plug these two values when you take the integral of the u cubed. Okay, so what you have here is 1/2, and then we have that the integral of u cubed is going to be u power 4 divided by 4, and then you evaluate from 2 to 5 the situation. So what you have is that this is going to be equal to 1/2, and then you have 5 to the power of 4 divided by 4 minus 2 to the power of 4 divided by 4, and then you have the situation. Okay, so as you can imagine, you can simplify this. This is going to be 1/8, and then you have 5 power 4 minus 2 power 4, and then you have that this is going to be 609 divided by 8. Okay, so that's going to be your result, but honestly you don't need to simplify as much as this. I would leave it either here or here. Okay, so moving on to a new problem. Over here you have that integral from 0 to 2 x divided by the square root of 1 plus 2x squared dx. So the first thing that you are going to recognize is you are going to use U-substitution, and this integral will give you a number because we have limits of integration. Okay, so the u is going to be 1 plus 2x squared, and the derivative of that is going to be 4x dx. Again, we don't have the 4, so you have that du divided by 4 is equal to x dx. That's what we have here and here. Again, the lower limit, you know that the lower limit 0, you plug it here, so you have 1 plus 0 is going to be 1, and the upper limit of integration, you plug the 2 here, so 2 times 2 is 4, 4 times 2 is 8, plus 1, that's a 9. Okay, so that's what we have. So you change your new integral is going to be from 1 to 9, okay, respecting the limits of integration that we have here. U to the power, since this square root is in the denominator, you know that that power is going to be negative 1/2, and then you have that it's going to be du divided by 4. Okay, now you integrate this. Okay, so we integrate u to the power of negative 1/2. You know that negative 1/2 plus 1 is going to be 1/2. Okay, here and here. Okay, and you're going to evaluate this from 1 to 9. Okay, so you have the situation. Then from here you can see that this is a 2/4, which becomes a 1/2. Okay, after that you know that u to the square to the 1/2 is square root, so you have the square root of 9 minus the square root of 1. Okay, so you do have that the square root of 9, what's that? A 3, and this is a 1, so you know that this is going to be 1. Okay, and that's your result. Okay, so let's look at the last one on this page. Okay, so we have that here, your U-substitution. As you can see, you have the integral from pi over 12 to pi over 9 sine of 3x dx. So your u is going to be equal to 3x, and then the derivative of that, you know that it's going to be equal to 3 dx. You can see that we don't have the 3 anywhere, so you are going to do a similar process. Du divided by 3 is equal to dx. So when we substitute here, you are going to have the du divided by 3. Okay, so the lower limit here, what you do is you have 3 times pi over 12, and that's going to be pi over 4. Okay, and then the upper limit that we have over here, what do you have? That it's the upper limit, 3 times pi over 9, and that's going to be pi over 3. Okay, So we change our new limits of integration. So my integral is going to be from pi over 4 to pi over 3, okay? And then we have sine of u, okay, du divided by 3. So this one we can rewrite as 1/3, and then you have that the integral of sine of u is going to be negative cosine of u evaluated from pi over 4 to pi over 3, okay? So what you have is the following. You have that this is going to be equal to 1/3, and then technically speaking you have that it's negative cosine of pi over 3, okay, minus minus plus cosine of pi over 4, close it, okay? So what you have here is 1/3, and then you have that it's going to be cosine of pi over 3, you know that it's 1/2, and the negative is negative 1/2, and this one is going to be root 2 over 2, and we can leave it like that, okay? If you want to simplify it a little bit more, you can obviously distribute this 1/3 here and here, and you would have something that looks like this, okay? Okay, over 6, okay? And that's your answer for this problem, okay? So for this example, we have the integral from 0 to pi over 6 sine power 3 x cosine x dx. So the first thing that you can recognize is the power of 3. That's telling you what's u. U is going to be sine of x. Then you have that the derivative of sine of x is going to be cosine of x dx. Therefore, you are going to change your limits of integration based on your new u, okay? So the lower limit of integration, you plug the 0 into the sign. What sign of 0? That's 0. And then the upper limit, you know that what sign of pi over 6? You know that that's 1/2. Therefore, I change my new limits of integration to 0 and 1/2, and then you have that it's going to be u to the power of 3 times du. Therefore, I can integrate this pretty easily with the u power 4 divided by 4, evaluated from 0 to 1/2. And then after that, you have that this is going to be equal to 1 over 4, and then you have that it's going to be 1/2 to the power of 4 minus 0, okay? So you have that this is going to be equal to 1 over 64, okay? Because this is going to be 16 times 4, okay? So that's what we have, okay? So let's look at the next problem. The next problem that we have over here, it's pretty much the same, but it looks different, okay? So find the area bounded by the graph of y equals x times square root of x squared plus 1 and the x-axis on the interval 0, 2. Okay, so this is your equation, okay? This is the graph of your equation starting here because of the domain, okay? So you have that this is x, this is y, so the area of interest here is from x equals 0, which is here, to let's say here, okay? That's your x equals 2, okay? So let's draw the line there so you can visualize what's going on. So the area of interest in this problem is going to be this one, okay? All that area. You can see that it's continuous, so we only have one integral, okay? So a new one from here to here. So you have that the area is going to be equal to the integral from 0 to 2 of this beautiful expression that we have here, plus 1, okay, dx, okay? So what you have is that your u, you can see that the u is going to be x squared plus 1. The du is going to be 2x dx, okay? And then here, the lower limit is going to be, you plug the 0 here, that's going to be a 1, and the upper limit, you plug the 2 over here, so 2 squared is going to be 4 plus 1, that's going to be 5, okay? So we change my limits of integration and my expression, and I'm going to have that it's from 1 to 5, and then you have that it's going to be u to the power of 1/2, okay, du divided by 2, because you can see that you don't have that 2, okay, even though I didn't put it here because I was running out of space, I put it here, okay? So you have that this is going to be equal to what? This is going to be equal to 1/2, and then I integrate the u to the power of 1/2, which is going to be u to the power of 3/2 divided by 3/2, okay? And then you're going to evaluate this from 1 to 5. You cancel the 2's, so what you have over here is a 1/3, okay, times, and what we have here is a 5 to the power of 3/2 minus 1 to the 3/2, but you know that that's a 1, so I leave it like that, okay? And you can just leave it like that, okay? So that's your area. You can put units square if needed. If not, you can just leave the number alone, okay? So that's going to be the area. Let's look at the last problem of this piece, okay? So we have that water is being pumped into a tank at a given rate by R of t. A table of values of R of t is given to you, okay? So we have selected values over here, 0, 5, 9, 15, 20, and then you have the outputs 14, 18, 20, 27, 32. We know that it's increasing, but you can see that this is 5, from here to here is 5, from here to here is 4, from here to here 6, and then 5. Use data from the table and force of intervals, okay, so how many they want? 4. To find the left Riemann sum to approximate the integral from 0 to 20 R of t dt. So you can see that here the integral is pretty much the representation of the area, okay? Since we don't have the equation here, your integral is going to be approximately the area of the left Riemann sum, okay? How can we compute that? With the force of intervals. You know that, recalling from previous classes, you have that the left endpoints, okay, in this situation, your left endpoints, we want 4, so it's going to be 0, 5, 9, and 15, okay? So you know that the base of the first rectangle is going to be from here to here, that's 5, times the height of that rectangle, which is going to be 14 because you are doing the left, okay? Plus then you have that base is going to be 4 times the height is going to be 18, plus then you have that this one is going to be 6 the base times 20, and last but not least you have that the plus is going to be 5 times 27, okay? And this is going to be equal to 397 gallons, okay? So that's going to be your result, okay? So you can have that this is going to be approximately 397 gallons, assuming that you are using the left Riemann sum. Now, if we want the right Riemann sum, what's going to be the business? Here they are telling you, use the data from the table and force of intervals, again 4, to find the right Riemann sum to approximate this. So you know that the right endpoints, okay, are not the same as the left endpoints. What are going to be the right endpoints? 5, 9, 15, and 20, okay? So you have that the integral from 0 to 20 R of t dt is going to be here, roughly the area of the right Riemann sum, and this area is going to be, the base is going to be 5, but the height is not going to be 14. This height is going to be from the table is going to be 18, okay? So similarly you have 4 times, and it's going to be 20 from the table, okay? And then you have that it's going to be plus, and you have that it's going to be here the base is 6, okay? And we're going to take the right Riemann, so that's 27, and plus the last one that we have over here, it's 5, okay, the base, and the height of this one is 32, okay? So this should give you that this value is going to be 492 gallons. So the integral from 0 to 20 R of t dt, using the right Riemann sum and force of intervals, gives you approximately 492 gallons, okay? And that's pretty much it for today. I hope that you find this video helpful. Bye!